Exploring Pi, Part 2. More Pie Plates by Jeff Simpson. In the Part 1 video, we did an experiment that enabled us to compare the distance around a circle to the distance across the middle of the circle. This video introduces some follow-up experiments that also compare the distance around a circle to the distance across the middle of the circle, but the circles will be of different sizes. In the Part 1 video, we took two pieces of copy paper and taped the edges together to make a cylinder. The edge of the two papers was 22 inches long when they were laid end to end and taped together, and the edge still measured 22 inches when the papers were rolled to form the circumference of a circle. We made another cylinder with two other sheets of copy paper, and then put one cylinder inside the other to stabilize the round shape. Then we put a 7-inch plate down inside the cylinder and laid it flat on the bottom. The diameter of the plate was 7 inches. The circumference of the plate was the same as the circumference of the cylinder, namely 22 inches. We found that the ratio, comparing the distance around the plate to the distance across it, was approximately 22 to 7, depending on how well your plate fit inside the cylinder. A number over a number means you can divide. Dividing 22 by 7 gave us two different results. The quotient can be 3 1/7 or 3.142857 repeating. The 22 to 7 ratio is called pi, and it can be reduced or simplified from that fraction form by dividing 22 by 7. So if we do that, the 22 compared to 7 ratio can look like these three other ratios. They're all the same. The ratio comparing the distance around a square, that's the perimeter, to the distance across it is 4 to 1. If you double the distance across, is the ratio still 4 to 1? Well, here we have a ratio of 8 to 2, but that can be reduced. So yes, the reduced ratio is 4 to 1. If you double the distance across, again, is the ratio still 4 to 1? Well, here we have a ratio of 16 to 4. And yes, the reduced ratio is 4 to 1. But what if you cut the distance across in half? Instead of 1, it's only a half. Is the ratio still 4 to 1? Well, going around the outside, a half plus a half plus a half plus a half, the perimeter is 2. So we have a ratio of 2 compared to 1/2. Now that looks a little troubling, a number over a fraction. What do we do with that? Well, we could multiply both numbers by 2. Let's see what happens. It gives us 4 over 1, a 4 to 1 ratio. So the expanded ratio is 4 to 1. Here's another way to look at it. The ratio 2 compared to 1/2, a number over another number tells us to divide, so we can do 2 divided by 1/2. Usually, to do this, we invert and multiply, so it changes into 2 times 2, which is 4. 4 over 1, or 4 compared to 1, is our ratio. The ratio comparing the distance around to the distance across is the same for all squares. It's always 4:1. Well, what about circles? Is the circumference to diameter ratio always the same for all circles? This ratio is 22 compared to 7. But what will this ratio be? Something compared to 3.5. And what will this ratio be? Something compared to 14. Let's do a new experiment that will help you figure out the ratios for these other circles. Instead of 2 pieces of copy paper as we did in the Part 1 video, this time use only 1 sheet of paper. So instead of 22 inches, this is only half as long, 11 inches. Roll the paper into a cylinder and tape the edges together. Now, instead of a plate with a 7-inch diameter, get a round object that is only half as wide. A 3.5-inch coaster will do. Now fit the coaster inside the cylinder. Does it fit tightly? It should. The diameter of the coaster is 3.5 inches, but what is its circumference? The circumference of the cylinder is 11 inches, so the circumference of the coaster must be 11 inches. The ratio comparing the distance around the coaster to the distance across it is approximately 11 to 3.5. This ratio can be simplified by using fractions. 3.5 is actually the same as 7 halves. So our ratio 11 compared to 3.5 can also be stated as 11 compared to 7 halves. It's the same thing. But we have a number over a number, so that means we can divide. 11 divided by 7 halves. Usually, though, what do? We invert and multiply, so it's 11 times 2/7. And look what it gives us. 22/7, or 22 over 7, or the ratio 22 compared to 7. So our ratio, 11 compared to 3.5, is actually equal to the ratio 22 compared to 7. This ratio can also be simplified using decimals. Instead of 3.5, we'll call it 3.5, or 3 5/10. So here's our ratio, 11 compared to 3.5. We'll divide both numbers by 3.5, and guess what that gives us? 3.142857 repeating compared to 1. And we can round that and just say that's like 3.14 compared to 1. So these two ratios are actually equal. Here's another experiment for you to try. Use 3 pieces of copy paper, making 33 inches when they're all taped together end to end. When you make a cylinder from the 3 papers, the circumference will be 33 inches. Now, if you put 3 of these coasters, each one is 3.5 inches, we put them side by side, how wide would they be all together? 10.5 inches, because 3.5 times 3 is 10.5. If you got one paper plate as wide as those 3 put together, it would be 10.5 inches wide. Try putting a 10.5 inch paper plate inside the cylinder with a 33-inch circumference. Does it fit well? It should. The ratio comparing the distance around the big plate to the distance across it is approximately 33 to 10.5. So here's our ratio comparing the circumference to the diameter. It's 33 compared to 10.5. This ratio can be simplified by using fractions. 10.5 is the same as 21 halves. So our ratio can be restated as 33 compared to 21 halves. Number over number means we can divide 33 divided by 21 halves. Now invert and multiply. 33 times 2 21sts. It makes it a little easier if we can cross-cancel. Gives us smaller numbers. And the final result, 22 sevenths, or 22 compared to 7. So our ratio, 33 compared to 10.5, is actually equal to 22 compared to 7. It's the same ratio. This ratio can also be simplified by using decimals. Instead of 10.5, we'll call it 10.5 or 10 5/10. Here's our ratio, 33 compared to 10.5. Divide them both, and the result is 3.142857 repeating compared to 1, and we'll round that to 3.14 compared to 1. So these three ratios are all equal. 33 compared to 10.5, 3.14 compared to 1, 22 compared to 7. The ratio comparing the distance around a square to the distance across it is the same for all squares. It's always 4 to 1. The ratio comparing the distance around a circle to the distance across it is called pi. That's the letter P in Greek. Pi is the circumference compared to the diameter, or circumference divided by the diameter. Pi stands for perimeter or periphery. The ratio comparing the circumference of a circle to the diameter is the same for all circles. The ratio is always 22 to 7, or 3.14 compared to 1, or 3 1/7 compared to 1, and those are all called pi. Pi is approximately equal to 22 sevenths, or 3.14 compared to 1. The last experiment in this video involves pizza. Some large pizzas have a diameter of 14 inches. You can get cardboard pizza circles with a diameter of 14 inches. They're used for cutting the pizza on and for serving. What is the circumference of this 14-inch pizza circle? They're also called pizza rounds. Well, how many sheets of copy paper would you have to tape together to wrap around the circumference of this pizza round? Here's a hint. Let's use what we know already. It takes 2 sheets of paper to wrap around a 7-inch paper plate. The ratio comparing the circumference to the diameter is approximately 22 to 7. So this ratio is 22 compared to 7. What will this ratio be? Well, something compared to 14. Hint, if you double the 7, the smaller diameter, multiplied by 2, you get 7 times 2 is 14. Question, if you double the 22, multiply it by 2, will you get the larger circumference? 22 times 2 is what? What do you think? Continue the experiment to see if your thinking is correct. After you find the circumference of this pizza round, can you reduce the ratio or simplify it? Well, we've seen several examples comparing the distance around a circle, that's the circumference, to the distance across the circle, that's the diameter. In every case, the ratio is 22 compared to 7, or 3.14 compared to 1. There's more to learn about pi, but this is enough for now, so that's all for the Part 2 video. Thanks for watching. And please share these ideas with other people who can benefit from them.